Probability. Now probability is basically number of favorable outcomes of any event divided by total number of outcomes. For example, if we have a dice, then for example I am going to find the probability that 5 will come in case of throw of a dice. Now, if we can observe a dice, then on a dice, 5 is present only once. We can get 5 only one time divided by total number of outcomes, which are 6. Total number of outcome mean in a throw of a dice we can get 6 possible outcomes: 1, 2, 3, 4, 5, 6. So probability of getting a 5 will be 1. That is because 5 can occur only once. Divided by 6, there are 6 possible outcomes. So this is basically the concept of probability, basically the chance of anything to happen. Now, question is, from one throw of a dice, find the probability of getting an even number, a multiple of 3, a number 7. Now, in solution, I have written here sample space. Now, what is sample space? Sample space basically reflects all the possible outcomes that are basically expected from throw of a dice. In this case, when I will throw a dice, I may get 1, or I may get 2, I may get 3, I may get 4, I may get 5, and I may get 6. So these are possible outcomes as a result of throw of a dice. Now I am talking about probability of even number. Now if I will observe the outcomes from a dice throw, then out of these outcomes I have 2, 4 and 6. These 3 outcomes are basically even numbers. So out of total outcomes, which are 6, I have 3 even numbers. Total we have 6 outcomes. So probability of getting an even number is 3 divided by 6, and on simplification it is 1 by 2. If we have to find probability of a number which is a multiple of 3, I will again go to my sample space, and from this sample space I will look for the numbers which are multiple of 3. Like 3 is a multiple of 3, 6 is a multiple of 3. So from this sample space I have 2 possible favorable outcomes, that is 3 and 6, which are multiple of 3. So here I will be writing 2, which are my favorable outcomes, while total outcomes are 6. So 2 divided by 6 is 1 by 3. Probability of 7. In this sample space we don't find a 7. So definitely the possible favorable outcome will be 0, because 7 is absent in this sample space. However, the total outcomes here will be 6, which is basically written here 7, so you can write here 6. So 0 divided by 6 is 0. Next is probability of an event not occurring. Now look at this formula: probability of an event occurring, that will be equal to 1 minus probability of an event not occurring. 1 represents total probability, and if you subtract probability of an event not occurring from 1, you will get the probability of an event occurring. So let's do a question. From a bag of 8 colored counters, the probability of not selecting a green counter is 0.25. Calculate the probability of selecting a green counter. So probability for green counter will be 1 minus probability of not selecting a green counter, and probability of not selecting a green counter is 0.25. So 1 minus 0.25 will give you 0.75, which is probability of green counter. Now next is relative frequency. First of all, let's see this question. Ali throws a drawing pin in the air and records the number of times that it lands with its point up. The table below shows his result. It should be his results. Number of trials mean how many times he has thrown the drawing pin and how many times it is pointing up. Against 10, 8 times it will point up. If you will throw it 20 times, then 13 times it will be pointing up. When number of trials are 100, then 38 are the outcomes in which point up will be the case. Similarly, when you have 1000 trials, then 355 times it will be its point up. Now what they have asked us, what is the relative frequency of drawing pin landing point up in 100 throws. Now relative frequency after 100 throws is basically number of times drawing pin lands point up, and that is 38. If you can see here, 38 times it is point up. And what are total number of trials? That are 100. So total number of trials is 100. So 38 divided by 100 is 0.38. So this is basically relative frequency after 100 throws. Now what will be the best, write down the best estimate for relative frequency of drawing pin landing point up. Now in order to find the best estimate for relative frequency, you will have to go for maximum number of trials, that are 1000, and out of these 1000, 355 times it will point up. So for best estimate, you will be going for 355, that is number of times it will point up, divided by 1000, which are basically total number of trials. So for best estimate, we will go for maximum number of trials. So answer will be 0.355. Now this is the concept of relative frequency. The probability of combined events. Basically, we have two types of event. One is independent event. Now what is independent event? When the first event has no effect on the second event. I will be discussing this in my example. Second one is dependent event, when the first event has an effect on the second event, effect on the results basically. So basically we have two rules, use of and or rule in finding probabilities of combined events. Now, if I have to find probability of first event and I have to find probability of second event, then I will multiply probability of first event with probability of second event. So whenever and will be used, you will multiply the probabilities. However, if I will be finding probability of first event or probability of second event, then I will be adding probability of first plus probability of second event. So when or will be used, we will be adding the probabilities. Now I will be discussing independent case when first event does not depend on the second event. Question is, from two throws of a dice, find the probability of getting. Now I will be throwing dice two times. Now I will be finding the probability of two sixes in two throws. So probability of 6 from first throw, when you will throw your dice first time, you will be having probability of 6 as 1 by 6, because 1 can come one time and total number of outcomes is 6. And when I will throw my dice second time and I will be finding the probability of getting a 6, it will again be 1 out of 6, because 6 can come only one time out of total outcomes are 6. Because and is used here, so we will be multiplying the probabilities, and 1 over 6 is equal to 1 over 36. Now the second is 1 6 followed by an even number. So I will be calculating the probability for 1 6. Probability for 6 is 1 out of 6, because 6 can come one time and total outcomes are 6. And I have to find probability of coming an even number. Now in case of an even number probability, I have three even numbers in a dice, 2 4 6. So three even numbers can be one of our favorable outcomes divided by total outcomes, which are 6. So it will be 3 over 6 into 6, 36, and on simplification you will get 1 by 12. And in the third case, a 6 from either side. Now in case of either, you have a choice. Either side mean you have a 6 from first dice, or you have a 6 from second dice. In case of 6 from a first dice, 6 can come one time and total outcomes are 6. And for second dice, 6 can come one time out of total outcomes, which are 6. And because we have been considering OR here, so I will be adding the probabilities, and 1 by 6 plus 1 by 6 is 2 by 6, and your result will be 1 by 3. So this is the case of independent events, when one event does not depend on the second. I have thrown dice twice. In first throw I will compute my probability, and then again I will throw my dice and I will compute my probabilities again. So first throw and second throw are independent of each other. Now in case of dependent events, so I will be doing this example, 3 red, 10 white, 5 blue, 2 green counters are put into a bag. So we have a bag and we have 3 red counters, 10 white counters, 5 blue counters and 2 green counters in it out of 2 selections without replacing. Now this is important. Without replacing. Without replacing mean we have a dependent case, because when I will be taking out any one counter from red, from white or from blue, I will not be replacing it back into the bag. So when I will not be replacing it back, it means that my second selection will be affected from first selection. So find the probability of getting 2 red counters. Now, probability of first red counter when I have a total of how many counters? If I will be count 3 red plus 10 white, 10 plus 3 13 plus 5 18 and 2 total counters are 20. And how many red counters are there? 3. So when I will be going for my first selection, I will be having 3 red counters and total counters in the bag will be 20. So my probability in first selection will be 3 out of 20, and when I will be going for my second selection, I have taken out 1 red counter. After taking out 1 red counter, I will be left with 2 red counters instead of 3. And because I haven't replaced red counter into the bag, that's why they have told us here without replacing 1 red counter, this one is not replaced. So out of 3, 1 is out, I am left with 2, and out of 20, 1 is out, taken out, so I am left with 19 in the bag. So this is the result of second selection and it is affected from the first selection. So now the probability will be 3 into 2, whatever it is, 6, and 20 into 19. On simplification, 2 and 20 will be cancelled out, so 3 over 190 is the answer. In this case, dependent case, no, this was the dependent case. Now in the second one, when I am going to have a red and a blue counter in that order, mean first I have to choose my red counter and then I have to choose a blue counter. So this is my first selection, and in case of first selection, total counters are 20 and red counters in case of first selection are 3, as the situation is. So 3 out of 20 will be the result of red counters probability. Now second selection is affected because I have taken out red counter and instead of 20, now I have 19 counters in the bag. And in the second selection, I have to take out a blue counter. So I have how many blue counters? I have 5 blue counters here. So I will be replacing this with 5. This is by mistake. So 5 blue counters and total counters after taking out a red counter is 19. So my result will be 3 over 76 after simplification. Similarly, I will be going to choose a red counter and a blue counter in any order, mean either we will be having red counter first and then blue, or we may have a blue counter first and then we have a red counter. So if we have a red counter first, then red are 3 and total are 20. And this is the first selection. After this, when I will be going for my second selection, total number of counter will be reduced from 20 to 19 as I have taken out a red counter. However, blue counters will remain the same because I have taken out a red counter and it will not affect number of blue counters. However, total will be affected. So in this case 3 over 20 for red, and for blue 5 over 19 will be the result for this case. Now if I change the order of selection, here red was first and blue was second. So in this case, if I will be choosing blue first and red second, so probability of blue will be 5, as I have 5 blue counters here you can see, and total counters is 20 20. So 5 out of 20 will be the probability for blue counter. Multiply by, because and is used, probability of red counter. Now red counters are in 3 number, so red counter number of red counters divided by total counters are now 19, because I have taken out a blue counter here. So you will be getting 3 over 76 from here, and you will be getting 3 over 76 from here, and upon addition you will get 3 over 38. So this is the case of dependent events. And now I am going to talk about the possibility diagrams. Now in this diagram is usually helpful when we are going to solve our question in case of multiple, that is combined events basically. So I have thrown a dice, first dice and second dice simultaneously, and I am adding the results. Suppose I have got a 1 on first dice and I have got a 1 on the second dice. So if I will be adding the results of both the dice, 1 plus 1, then what will be my result? 2. Similarly, if I will be getting a 2 on first dice and I will be getting a 1 on second dice, then my result will be 3. 2 from first dice, 1 from second dice, 2 plus 1, 3. Similarly, I will be getting 4 if I will be getting 3 on first dice and getting 1 on second dice. 3 plus 1 is 4. So these are the results of addition of the output of the dice that we are getting from the two dice that are thrown simultaneously. So find the probability of getting a total of 10 from a throw of 2 dice. So how many times I will be getting 10 if I throw 2 dice? So here you can see this is 10. If one dice, if suppose I will be getting 4 on one dice and I will be getting 6 on the second dice, so 6 plus 4 is 10. So one time I will be getting 10 in this way, again I will be getting 10 second time, because if one dice has 5 and the second dice also has a 5, so 5 plus 5 is 10. So 10 will be coming 3 times in case of throwing dice, 2 dice. So these are the possible outcomes. So how many times I will be getting 10? I will be getting 10 3 times. And what are the possible total number of outcomes? That are 36 when I will be throwing 2 dice. Total number of possible outcomes are 36, and favorable outcomes, that is 10, are 3. As you can see here, it is colored in yellow. So 3 over 36 on simplification will become 1 over 12. So if you want to calculate total number of possible outcomes, so this shaded region shows the outcomes from the 2 dice. This is one outcome, this is second outcome, third outcome, fourth, fifth, sixth, and this is seventh outcome, eighth outcome, ninth outcome, 10th outcome, 11th outcome, 12th outcome, and if you will calculate up till here, you will be getting 36 outcomes. So total outcomes are 36, and out of 36, 10 comes how many times? 3 times.